Greetings, ladies and gentlemen. My name is Reb Himounia Hibat Rahman, a second-year computer science engineering student at Easy Algiers, and I would like to welcome all of you to the second track of DevFest23 Algiers journey, DevFest23 Talks. Before we officially kick off our discussions, I'd like to take a moment to introduce JDG Algiers, the esteemed host of this grand event. JDG Algiers stands as one of the many chapters of the Google Developers Group, a global project by Google uniting developers worldwide. Established in 2011 and headquartered at Easy Algiers, our chapter holds the distinction of being the most active and largest in the MENA region. Our primary objective at GDG Algiers is to foster the exchange of diverse experiences and knowledge regarding Google technologies among like-minded members. Everyone present here is dedicated to delivering high-quality content, organizing engaging events, and undertaking creative projects, all while ensuring a lively atmosphere. Speaking of creativity's fruits, let's shift our focus to one of the most significant ones, DevFest. The Developers Festival, or DevFest, is an annual international event organized by Google Developers Groups, GDG Worldwide, uniting local developers and tech enthusiasts. This year, in 2023, GDG Algiers is proudly hosting its 12th edition of this event. The journey began in October with DevFest23 challenges in various tech fields, and now we are advancing to the second phase, the DevFest23 talks. These online sessions serve as a platform where experts share their insights on various topics, allowing you to explore networking opportunities and stay updated on the latest tech trends. Without further delay, let me introduce our first speaker, Yacine Zidelmal, a DevOps engineer at SilaInsights. Yacine is deeply passionate about Docker, Kubernetes, CI/CD pipelines, and cloud infrastructure. In his talk, he will delve into the world of infrastructure as code. A warm welcome, Yacine Zidelmal.
Thank you, Moni. So a brief introduction about myself. My name is Yacine. I graduated from Easy a couple of years ago, and so it's a great pleasure to be in the community again. So after my graduation, I worked as a DevOps engineer for a couple of companies, and I'm currently working for SilaInsights. And I'm specifically excited today to be here to talk about infrastructure as code, which is known as IAC. And it's really a game changer when it comes to efficiency and automated and scalable IT environments by seamlessly merging software development and infrastructure management. So I would like to remind you that this talk is beginners friendly, so don't worry if you don't know much about the foundations of infrastructure as code.
راك مدير المايك تاعك muted.
Really? Was it like from the beginning? وين حبس الميكرو تاعي؟ أنا مش عارف تاعي. I think there was a technical issue. I'm not sure if you guys didn't hear me since the beginning. Should I come back again from the beginning? Monia, can you hear me, please? Yeah, Osama, can you hear me? Hey, Osama, can you hear me, please?
Yes, I can hear. There was just technical something. So you can restart from the beginning. Or...
Yeah, sure. Yeah. I can go back again and. Yeah, so as I said, a brief introduction first about myself, in case this was muted as well. My name is Yacine, and I graduated from EASY a couple of years ago, so it's a great pleasure to be among the community again. And after my graduation, I worked with several companies as a DevOps engineer, and I'm currently working as a DevOps engineer at SilaInsights. I'm specifically excited today to talk here about infrastructure as code, which is also known as IAC, and which is a game changer for efficient, automated, and scalable IT environments by seamlessly merging software development and infrastructure management. Just to remind you, this is beginners-friendly talk, so don't really worry if you don't know much about IAC. We'll begin from the basics and we'll take it step by step. First, we'll introduce the concept of IAC and explore the different types of infrastructure as code. Next, we'll dive into the comparison between mutable and immutable infrastructure. We'll also introduce a key IAC tool, which is Terraform in this case. And if we have enough time by the end, we can wrap up with a demo of IAC in action. So let's just kick things off from the fundamental question: what is infrastructure as code, and why is it so important, having 30 minutes or 40 minutes presentation about it today in DevFest GDG. So, and to understand this, let's take the journey back to a time when the process of provisioning infrastructure was a complex and time-consuming task, where the software delivery process used to look pretty much like this. It all begins with the business requirements, which is a vision that needs a technical solution. This vision then transitioned to the development phase, where teams craft the code that would bring the solution to life. And as the development phase concluded, the focus now shifts to deploying the solution in the underlying infrastructure. The traditional approach often involves manual steps, and where IT professionals would configure servers, set up networks, and handle various dependencies. The process was not only resource intensive, but also prone to human errors, leading to delays and potential issues in the deployments. So this intricate dance between deployment and development and infrastructure often resulted in prolonged timelines and challenges in maintaining consistency across different environments. It was like Word, where infrastructure provisioning was more of an art than a science, and scalability was a persistent challenge. Scalability is always a persistent challenge. It wasn't only; it's still a persistent challenge. So now, like fast forward to the present era of modern infrastructure delivery, where the cloud has literally transformed the landscape. Cloud computing provides with agility and flexibility with just a few clicks. Here, for example, in the Azure console, we can access infrastructure on which we can deploy our applications. However, while the cloud brought its immense possibilities, manually using this management console specifically and from other providers for infrastructure provisioning quickly revealed its limitations. So using this management console might be suitable for smaller infrastructure, but in the context of large organizations with fast, elastic, and highly scalable cloud environment, the traditional approach becomes impractical. And the sheer amount of work involved and the risk of introducing human errors makes it an unsustainable method for managing infrastructure at scale. So to address this challenge, the solution emerged through automation and infrastructure as code, which is known IAC. Cloud environments expose APIs, and that opens up a whole new world of possibilities for automation. Recognizing this, there was the need actually for a consistent and automated approach to infrastructure provisioning. This need for automation led to the development of a set of tools collectively known as infrastructure as code, or IAC. Initially, this involved actually basic shell scripts and scripts from various programming language. However, this evolved into more sophisticated set of tools designed to streamline and automate the infrastructure provisioning process, providing a consistent and at the same time scalable solution. So as we explore the realm of infrastructure as code, we'll witness how this evolution has revolutionized the way we manage and provision infrastructure in the cloud, bringing efficiency, scalability, and repeatability, most importantly, to the forefront of modern software delivery. So as you may be aware, the trivial way to provision cloud infrastructure is via the management console. And in this case, this picture, it's AWS Management Console. And a better way to do that is by actually codifying the infrastructure provisioning process. This way, we can write code to define, configure, and eventually destroy infrastructure resources. And this is what's called infrastructure as code. So with IAC, you can manage nearly any resources as code. And in any resources, I really mean it, like virtual machines, databases, networks, storages, to name a few. And this example over here is a shell script that creates an EC2 instance on AWS. However, it's not easy to maintain and it's not easy to manage as well. And the problem with shell scripts is that for each script that you create to provision resources, you will need a script that takes down these resources whenever they are not anymore needed, meaning that there is a lot of logic that needs to be coded. And that's where tools like Terraform and Ansible help with code that's easier and more human readable. So, for example, this shell script here can be translated easily to a simple Terraform script like this. And with IAC, we can define infrastructure resources using simple and human-readable high-level language. Here is another tool, which is Ansible, and this is another Ansible playbook to provision one EC2 instance on the cloud. Now, although Ansible and Terraform are both infrastructure as code tools, they have some key differences in what they are trying to achieve. And as a result, there are some differences in the real use cases of them, and we'll see them in the next slide. So there are several tools as part of the IAC family: Ansible, Terraform, Puppet, SaltStack, CloudFormation, Vagrant, Packer, and a lot of other tools. And IAC can be broadly classified into two main categories. The first one, which is config management with tools like Puppet, Ansible, and SaltStack. And the second category is the provisioning tools like Terraform and CloudFormation from AWS. Let's take a closer look into each one of them. Let's start from the config management tools. Tools like Ansible, Puppet, and SaltStack are designed to install and manage software on existing infrastructure resources. What differentiates them from shell scripts is that these tools follow a standard structure, and they are easy to maintain, and they can also easily be checked out to a version control system for collaboration and history tracking. The second type, which is the provisioning tools, which is specifically of interest to this talk. These tools are used to deploy immutable infrastructure, such as servers, databases, network components, to name a few, on multiple cloud providers. Now, while CloudFormation is used to deploy resources on AWS specifically, Terraform is vendor agnostic, which means it can be used on any infrastructure provider. However, the most important feature on both of these types, which is provisioning tools and config management tools that we have seen in the previous slide, is that they are idempotent, which means that you can run the code multiple times, and each time you run it, it will only make the changes that are necessary to bring the infrastructure from the current state to the desired state. I'm sorry. And it would leave anything that's already existing as it is without us having to write any additional code for that. Now, before we move to see one IAC tool in detail, which is Terraform today, we need to understand a couple of key concepts here. Let's start from immutable infrastructure, because we have mentioned previously immutable infrastructure, but what does it mean exactly? I'm sorry, just 1 second. Well, for immutable infrastructure, in order to understand that, let's take this scenario. Imagine we have a server running version of some software, for example, Postgres in this case, and it's running version 1.12, which is just an imaginary version. This is not a version of Postgres, it's just theory. When the new version of Postgres is released, we upgrade it from 1.12 to 1.13, and we do the same thing to upgrade it to version 1.14 when it's released. And this can be achieved by various ways, by writing shell scripts or executing Ansible playbooks to carry out this upgrade operation. Now, usually for the sake of high availability, we don't have one server, but rather we have a pool of servers. In this example, we have a pool of 3 servers, for example, running the same version of Postgres. We would use the same approach to upgrade the version of Postgres every time there is a new update. This type of update here is known as in-place update, where the software and the configuration are changed as part of the update, but the underlying infrastructure remains the same. This is here an example of mutable infrastructure. But we know that updating software is often a tedious task where a set of dependencies need to be met before the upgrade operation can be carried out successfully. Let's assume now that we have the first 2 servers that meet all the dependencies, while the third one does not. So the upgrade operation will be successful on the first 2 servers, while it fails on the third one, on the third server. So now we have the third server still running the version 1.13, while the 2 others are already upgraded to 1.14. So the important thing to note here is that now we have a pool of servers where one of them is running different version of software as compared to the others. And over time, with multiple updates, there is a possibility for the servers of this pool to vary from one another, maybe in software versions, configurations, or sometimes even in the version of operating system when some operating system upgrade fails. So, and this is known as by the name of configuration drift. And it leaves the infrastructure in a complex state, also known as undefined state, which makes it harder to maintain and carry further updates. So instead of updating Postgres now, let's take the other scenario of immutable infrastructure. Instead of updating Postgres in the existing servers, let's spin up a new server and install the new version in it and take down one of the old servers, which is the one in the left side here, and we bring up a new one in the right side. We continue to do the same thing for the rest of the servers one by one until we have 3 servers running the correct version v1.13. This is known as immutable infrastructure. So immutable means unchanged or something that you cannot change. And as a consequence, with immutable infrastructure, we cannot carry out in-place updates in the resources anymore, right? And this allows better versioning of the infrastructure and makes it much easier to do rollbacks and roll forwards between versions. With this concept explained, I think we can start exploring one IAC tools and see how it works in action, which is Terraform, obviously. Terraform operates in the immutable infrastructure mode that I've just explained. And Terraform is a popular IAC tool that's specifically used as an infrastructure provisioning tool. It's free and open source, developed by HashiCorp. It allows to build, manage, and destroy very complex infrastructure in a matter of minutes, really. So one of the biggest advantages of Terraform is that it's vendor agnostic, which means that it's able to deploy infrastructure across multiple platforms, including public and private cloud. These are just few of many resources that Terraform can manage. And you might be wondering actually how Terraform manages all of these components in different vendors. And this is achieved through providers. Terraform follows the plugins architecture, which makes it possible to plug any provider to the core Terraform architecture. So a provider helps Terraform to manage third-party platforms through their APIs, and as a result, it can manage cloud providers such as AWS, GCP, Azure, vSphere from VMware, and as well as Cloudflare, for example, and Big IP as network tools, as well as data platforms like Datadogs and Grafana and databases as well. So there are hundreds of such providers, making it possible to manage various types of infrastructure from a large list of vendors. Terraform is based on HCL, which stands for HashiCorp Configuration Language, which is a simple, declarative, human-readable language to define the resources to provision cloud infrastructure, basically. So this, for example, is a Terraform code to provision a storage account on Azure. It's declarative, and it can be checked out into a version control system for collaboration. So now we have said declarative, but what does it mean? So to explain this in general, we have two programming paradigms, imperative and declarative syntax. And in the imperative one, it's about providing explicit step-by-step instruction, similar to a detailed recipe guiding each action. And on the flip side, declarative infrastructure focuses on expressing the desired end state without dictating the exact sequences of steps. It's resembling actually ordering a meal where you state what you want and leaving the chef to decide how to prepare it. And Terraform is a declarative language, which means that we only specify the desired state of the infrastructure, and Terraform takes care of converging the current state into the desired state. But how does it do that, right? So let's go back to our previous script that creates storage account on Azure. So storage account is just a component of Azure to store data, basically. Think of it like this. It stores files and tables and stuff, basically unstructured data. So the code over here is the desired state, and the one on the right side is the current state where there is nothing basically initially. Terraform will take care of configuring and figuring out actually what's required to bring the current state to the desired state. Terraform works in three phases, which is also known as the life cycle of Terraform. First, the init, where it identifies the required providers. And the second one is the draft plan, which is the command Terraform plan that creates a draft plan on how to bring the current state into the desired state of our cloud infrastructure. And the third one, which is apply, that applies the changes on the real infrastructure. So now let's begin to delve a little bit deeper into the HCL syntax very quickly. So the HCL file is composed of blocks of arguments, and a block enclosed in curly braces contains a series of arguments in a key value pair format, representing the configuration data of that resource. And in its simplest form, a block provides information about the infrastructure platform and the set of resources within the platform that we aim to create. And let's consider, for example, this straightforward task of creating a file in the local system where Terraform is installed, basically. We can define resources by a resource block with the file name and the content specified as block arguments. And let's break this down into small chunks. So breaking down the file, the first element is the block itself, which is recognized by the curly braces. And the specific type of this block here is resource. And let me show it here, is this resource because there are multiple types of blocks in Terraform. And the following it with the keyword is the declaration of the resource type we want to create. So the resource type is provider specific, so it's very specific to the provider you are using. and it's determined by the provider where we intend to create the resource. And in this case, the resource type is local file with local, which is the provider, and the term after the underscore, which is file, which is the resource itself. And then we have the name of the file and the configuration required to create a file in the current file system, which is the file name here and the content, the basic content of the file name. So it's important to note here that here the two arguments, file name and content, are very specific to the local file resource. So if you need to know what specific resource needs as arguments, you will need to check out the documentation in Terraform website /providers. You will find an entire list of providers, each one with documentation of the required parameters for each resource. I think that for the rest of the syntax, just to save some time, I think we'll explore it in the live demo. And we want to see things in action, basically. So let's start a quick demo before provisioning infrastructure on the cloud. We'll do it on the local machine, exactly the same way it's done here. So let me just stop sharing this. Can you see my screen now? Let me check. Okay, it's visible now. So this example here is just the same example that I showed in the slides, and I wanted to explore this because the basic concept that we have seen previously in the slides can be easily seen here. While we have resource, which is local file, and this part over here is the name of the provider. The second part is the name of the resource itself. And this is the name of the resource inside the file. It's an ID for this resource inside the file. And we have two required arguments, and we have a set of non-required arguments as well. But the file name is the path to which this script needs to save this file and the name of the file. And the content is the content of the file, basically. So I did run the script before, so I will just delete everything that I have done. So first of all, we need to do Terraform init, and by doing this, Terraform will recognize any provider that's used in this script and will download it as a form of binary, and it will save it in the Terraform providers and HashiCorp, and it goes to the local provider, which is the one that's used here. It's just a local provider that operates on the local file system. So by doing so, it will bring this provider and download the binary thread. Once done, we can do a Terraform plan. And for the sake of the demo, let's assume we didn't run it. So I will delete the file that was created previously. And by doing this, I will start fresh, basically. So the second command is Terraform plan, where Terraform shows the plan that it will be carried to bring the current state to the desired state. Now, the desired state, as is stated in this file, is that we want a file to be in this location and contain the current string, for example. So to do that, we need to run Terraform plan, and it will give us the plan that will be carried out to do this. So as you can see here, it's a create operation, and it will create this content file with a couple of a couple of arguments. File name is here, the content is here, and there are extra default values as well, so we don't care about that. Let's just trigger it by doing Terraform apply. So this will apply this plan basically, and this will go and create the desired resource for us. All right. So now this file got created, and it contains the exact string that we have specified over here in the Terraform script. Sorry. Now let's see the fact of immutability in real action. So let's say for the sake of this demo, we want to change the content of the file and replace it with something like GDG, for example, at the end of the content. And let's do a Terraform apply to see what's actually being executed. So now, what Terraform is telling us is that it will actually go and destroy the existing file and create a new one. And this is what we mean in immutable infrastructure. It doesn't go to the file and update it. It's rather go into the file, deleting it, and creating a new one. This is the concept of immutability in infrastructure. So let's try it again and see. Okay, and let's check the file one more time. Yeah, so it added this substring to the end of it. So this is the concept of immutability. Now, the concept of idempotency, let's see this in action. So for a traditional programming language, if you execute the same script again, what will it do? It will eventually create another file with eventually the same content, right? But if we do Terraform apply again, it will not do anything. It will basically see that there is a file already existing with the same content and nothing has changed, so it doesn't do anything. This is why Terraform is idempotent. So this is a basic example to show very basic stuff on core concepts of Terraform and infrastructure as code in general. But let's see more sophisticated example where we have some Azure infrastructure. You can use any cloud provider. You just need to update the provider and the resources. So in this case, it is a Azure Functions, which is a serverless type of compute. So we are using that to create an Azure function. So this is the definition of it. I don't want to go in depth in it. It's basically very specific to Azure. We need to instantiate a service plan and then attach a function after it. I just wanted to see it in action, like to see how it works in action. So I'll go to the other terminal where I have the yeah, it's open on the same folder. Yep. Let me just do this. Let's do a Terraform init first. This Terraform init will download the binary for Azure provider. And since it's already there, it's not downloaded. It's cached basically. Now, let's do a Terraform plan so that we can see the plan that will be carried out by this script. It might take some time because what it's doing, it's fetching what's called the state. I didn't mention that in the presentation. It's fetching the current state on Azure. So it sees if there is such an Azure function already existing or not. So since it's not existing already, it's given me the plan to create this infrastructure. And it's a good practice to go and check the plan and verify it before applying it. So I have already done that. So just let's do it. Yep, so it will eventually ask me for the permissions because it will update the infrastructure. So I see that it will create for me. So I will just share another window. Coming back. Okay, yeah, this is the infrastructure that was provisioned. And yeah, that's it in action. That's pretty much it, I think. Yeah, so if you have any questions, I would love to hear from you. If you want to catch me on LinkedIn, I'd be more than happy. Sama, are you here? Can you hear me, please? I'm not sure if the guys left or not. So let's wait for them for a moment. Sam, I'm not sure if you are here. If you are here, please show up.
Yes, I'm here. I think now we move to the questions. Well, thank you so much, Mr. Yacine Zidelmal, for your outstanding presentation.
Thank you. Yeah, if anyone has a question, I'm more than happy to answer it.
Well, in closing, we extend our gratitude for sharing your expertise in infrastructure as code. Your talk has been informative and enriching to our audience. For the audience who are watching, I encourage you to share any questions you may have in the comment section. Yacine will be monitoring and responding to all your queries. I will be reading the questions, so if you have any question, you can put them in the comments.
Seems like everything was clear in the presentation. Yeah, Zakaria. More questions on Python because I want to cloud infrastructure. Yeah, sure, Zakaria. Zakaria Ali. Yeah. Thank you, guys.
Amira here said, can we import files other than from our drives?
Sorry?
Amira said, can we import files other than from our own drives? She was talking about the files.
Yeah.
Yeah.
So the goal of that exercise of local file is to create actually resource basically, and for that we put the content of the file inside the file system. So I didn't really get that. Does she want to create the file in another file system, another drive system?
I guess that's what she's talking about.
Yeah, if that's the case, then yes. Infrastructure as code and specifically Terraform offers a variety of providers, and you can put the file, for example, an S3 bucket on AWS and Azure Blob Storage and the service account that I showed previously. So you can do that definitely. I don't know if I'm not able to read further questions, but can you see any other questions, please?
There are comments if you can see them, but there isn't any question. Here, Karim said, quick summary, please. I don't know.
Yeah, quick summary. We spoke about infrastructure as code. We have seen various types of infrastructure as code. We have seen the mutable versus immutable infrastructure and a few key concepts like idempotency, and we have seen as well Terraform in action. It was a quick introduction to Terraform. I intended to make it very beginners friendly. There are extensive concepts that you can learn from Terraform documentation, and yeah, that's it. And we did a quick demo on how to provision infrastructure using Terraform. Few questions. Amira Namdil asks, these versions, which versions are these? Is it for software or operating system? I think she means when we spoke about the configuration drift, where one server runs on specific versions of the software specifically, and I was explaining the case of Postgres, for example. It was just an example. So you can take this example of Postgres, and you can apply it to any software basically installed on those servers.
Well, we have a question here. In real work scenarios, do you use KAS provider in Terraform for deployments or other tools like Customize?
Both are usable. So we can use the Kubernetes provider. And I haven't used Customize before, but I work mostly with the Kubernetes provider. For Customize, I'm not sure, to be honest, but both can be used to provision infrastructure on Kubernetes. Let me go further up. Maybe there are a few questions. So Sylvia Shahili, I wish they make it simple because I'm literally L1 and still don't understand much stuff here, but it's cool. Well, if you understand actually that the fact that the infrastructure provision in Word is changing and that we are not actually provisioning infrastructure using manual steps on the cloud by click, we are rather codifying the entire infrastructure using tools like Terraform. This is a good start, and I think you can. This is a good start if you learn this, and then you can take it step by step for the next years in your career, hopefully.
We have another question here. How do you ensure the security of sensitive data when using AIC?
All right, yeah, this is a good question here. And IAC tools like Terraform support secrets, so you can use the secrets to make sure your sensitive API keys, for example, passwords, don't go public and they don't get logged in the stack of the Terraform plan and Terraform apply. So this is one thing. You can also ensure the security of your state of the infrastructure by saving it to some sort of backend in the cloud, S3 buckets, which is a very common way.
Okay.
I hope I answered your question.
Amira Namdil has another question. She said, infrastructure codes only include backend?
No. So infrastructure operates on the infrastructure level, which means it's not related to the software itself, but it's rather related to the infrastructure, which means the servers, the databases that are managed services on the cloud. But if you mean by infrastructure codes in Ansible, Ansible manages different types of software, not only backends.
There is another question. What are the most used cloud native application? I am referring to the cloud native landscape web page in my mind. He said,
Okay,
what
yeah,
are the most used?
yeah.
Okay.
This is a good question, and I would say, in my opinion, I don't have the exact statistics, but the most used one should be Kubernetes because it's widely adopted by companies and it offers high availability and it's the new cloud, let's say. So I think Kubernetes is the most used one, but I need again to check the statistics.
Another question: how do you approach troubleshooting when an IIAC deployment fails?
Yeah, that's a good question as well. So one straightforward thing to do is to see the logs of the Terraform apply and then see what happened and try again Terraform plan, and it will give you eventually some errors before even applying it. So you need to follow the stack and check what's wrong in your syntax, basically, or in the arguments that you are pasting inside the resources. Did I miss any Any other questions?
I guess
That's
there's-
it, yeah.
Yeah.
Yeah, I think that's it.
So thank you for the fruitful talk. We enjoyed it. It was
Thank
so much fun. It was so much. We learned. I'm sure they learned a lot. Thank you for coming.
Yeah, thank you so much. Thanks a lot. This is my pleasure, and I enjoyed it too. Good luck with the rest of talks. Thank you, guys.
Thank you. So don't forget to join us in the next talk about system alerting and monitoring by Nasir Hamza at 8:15.